All right, another triangular prism. This triangular prism has two faces, these two faces that are exactly the same. And it also has, looks to me like this is an isosceles triangle. It's not labeled properly, but it looks like these faces are going to be the exact same. So we have two pairs of similar faces. There is something interesting about this question, however. It labels some of the lines, but it doesn't label all of them. For instance, this line that I've indicated with a little dash, it doesn't tell us what that is, and we definitely need to know what that is. So in order to figure it out or to calculate it, we have to use Pythagorean theorem. Pythagorean theorem shows us the relationship with a right-angled triangle. It shows us the relationship between these three sides. And what it shows us is that a squared, the square root of a plus the square of b equals the square of c. Do we know on this little triangle here, the a, side a? Yeah, we do, 7. 7 squared. Do we know this down here? Well, the whole thing is 10, and so half of it is going to be 5. So we'll use this information to calculate c. That's 49. That's 25. We add those together using a calculator. That's 74. And 74 is not a perfect square. So we're going to get a decimal number here, but that's okay. We'll use it. Square root 74 is going to be 8.6. About 8.6. All right, so our length here is going to be 8.6. All right, now that we have that length, we just go ahead and label all the sides. So I'm going to do front, back. And if you like, we'll color that front, back, triangles. Okay, so I'm going to label as front, back, triangles. Let's make them orange. So it's going to be, in this case, how do you find the area of a triangle? The area of a triangle just needs to be base times height divided by 2. Now the trick with a triangle is the base and the height need to be perpendicular to each other. They need to be at right angles from each other. So it doesn't matter that it's the line goes all the way across. We just need two lines that are perpendicular from each other. So if we look here, it's 10 and 7. Some of you might be tempted to just use the 5 times 7. If you did that, you're only going to get half the triangle, like this. Okay, but you don't want half the triangle, you want the full triangle. So we're going to use 10 and 7. So 10 times 7 divided by 2. Now again, because there are two faces, this is going to be 70 divided by 2. But again, we're going to remember that we're going to multiply this whole thing by 2. So 2 times 2, or 2 divided by 2, they're just going to cancel out. So the front and back will be 70. Okay, orange with a little bit of blue on it is going to be 70. All right, let's go ahead and do this face here. So we have, let's call this left, right. Now, left, right seems to me they're going to be the same. This is 20, length is 20. This is 8.6, that's 8.6. So these are going to be the same. So we're going to have two of these. So we go 8.6 times 20. What's that going to be? Use a calculator. 8.6 times 20. 172. There are two faces, exactly the same. So I'm going to multiply that by 2 to get 344. That is our yellow faces. Now there is only one face left. Let's say it's green. It's the bottom. bottom, the green one. And what is it? 20 times 100. I don't need a calculator for that. I mean 20 times 10. It's 200. So that's what green is. So I add all of these together. 344 plus 200 plus 70 equals 614. Now they had 614.1. That's probably because they rounded a little bit differently than I did here. 8.6 times 20 is exactly 172. They probably got 172.5 or something to that effect. But as you can see, the answer is the same.